Let's look closer at one use of container technology. This is an example with which most of us here in this webinar can identify. It's audio mixing. We'll give you a quick overview here of how an AoIP system connects. It all begins with the IP network, and to that we add some audio in and out devices and GPIO devices. This is how we connect non-AoIP devices to that network, like speakers and microphones. Next, we'll add some more resources and destinations, perhaps computers running an IP audio driver. This connects audio applications directly to the AoIP network. Now to this, we can add an audio console along with its attendant mixing engine to that AoIP network. We now have a functioning AoIP network with an audio console and some ins and outs. Once the required audio sources and destinations exist on an AoIP network, we can easily add more consoles simply by plugging them into the network. In this case, here's an Axia IQX console, and it has the mixing engine built into it and works with LiveWire and with AES67 IP audio simultaneously. So here we have two studios in a hardwired AoIP network. Now, once that network has all the sources and destinations we want, we can attach more convenient and sophisticated applications to the mix. Let's take the next step here. A soft surface application can control an existing physical mixing console, or it can be the virtual mixing console controlling a mix engine on the network. Now, a range of virtual control applications make up the IP tablet series. IP tablet can control other mixers on the network, control on-air phone systems, audio codecs, IFBs and talkbacks, and monitor audio anywhere on the network. Audio mixing control can also be created using Axia's Pathfinder Core Pro system. Indeed, many broadcasters created custom mixers and other peripheral controls using one or more of these add-on software solutions. In the next slide, we're going to change several things, so watch closely. We're going to replace the hardware mix engine down in the lower left of the slide here with a PC server running a mix engine in a Docker container. We're also going to replace the hardware or software mixing applications with a laptop that's just running a standard internet browser. Here we go. Here we've deployed a PC server with the Linux and the Docker engine, and we've installed one IQS software container in it, which not only replaces the mix engine, it also has a web server built into it for configuration and a special web page that renders a beautiful, intuitive audio mixing console surface in a web browser. That's what we call IQS. And we're controlling it with that laptop using a standard browser. Now we can install more IQS mix engines in Docker containers and control their audio mixing with, say, a tablet attached to the network. And as the web page that shows that mixing surface, that web page isn't sending or receiving actual LiveWire audio, it's just a display and control, we can use non-wired connections like Wi-Fi and control additional IQS consoles with wireless devices like phones or iPads. The actual LiveWire and the AES67 audio stays on the wired network within the broadcast facility or data center. Now, with proper attention to secure access, IQS mix engines can be controlled remotely, even over the internet or, of course, over a VPN as well.